So this is the next question, 8b. Mention the design steps followed in the design of linear phase FIR filters. Okay, so this is one basic theory question. In the model paper they have asked it. So the design steps to follow to design linear phase FIR filters are as follows. First, consider the desired frequency response, that is HD of omega, and the desired samples impulse response or the sample response HD of n. Okay, so how these two are related to each other? These two are related to each other by, if you take the HD of omega, its Fourier transform, that is Fourier transform, Ft stands for Fourier transform of HD of n, we would be giving you the resultant of HD of omega. Therefore, HD of omega is equal to, take the Fourier transform of HD of n, that is summation n equal to 0 to infinity HD of n e to the power minus j omega n. This is the relationship between HD of omega and HD of n. So name it as equation 1 here. Now how HD of n is related to HD of omega? That is, if we want to find HD of n, we should be taking the inverse Fourier transform of HD of omega. That is, HD of n is equal to 1 by 2 pi with the integral of minus pi to pi HD of omega e to the power j omega n d omega. Like this, we should be finding for HD of n. Name it as equation 2, where this HD of n, the impulse response is of infinite duration, but we should be finding for finite duration. Okay, to make HD of n finite, we should be making HD of n finite by multiplying HD of n by the window sequence m. Okay, we should be using the windows now into the picture in order to design the linear phase FIR filters. In order to make it finite, we should be using the finite windows. So here in this case, one example, I have taken it as one rectangular window. So according to the definition of rectangular window, omega r of n is 1 for all the values of n from 0 to n minus 1, and it is 0 otherwise. So and now HD of n is sample infinite response. So in order to make it finite, we make it for HD of n, replace it by h of n by multiplying it with the rectangular window. That is, h of n is equal to HD of n into omega r of n. Okay, so this is the one equation. Write it as equation 3. So therefore, according to the definition of rectangular window, it is 1, right? So h of n, we can write it as h of n is equal to HD of n into 1 for all the values of n equal to 0 to n minus 1, and it is 0 else, right? So name it as equation 4. So this equation we have got for h of n after the windowing. Okay, so from equation 3, what we can do is h of omega, by taking the Fourier transform of h of n, we would be getting h of omega is equal to Fourier transform of HD of n omega r of n. So this is the final relationship, and in this way we should be designing the linear phase FIR filter. Okay, by using these conditions by keeping these conditions in mind. Okay, so please note these conditions down, very important ones. So I'm just going to scroll like this, so please note it down. Very important question. This would be coming for 4 to 5 marks. Okay, design part, you should be knowing each and every step and how where it is used, how it is related to each other, all of them you should be knowing. Okay, so note it down. Design part, you should be knowing each and every step and how where it is used, how it is related to each other, all of them you should be knowing. Okay, so note it down. This is the next question, 8c. Realize a cascaded form FIR filter for the following system function. So this is the next question. Again, they are mentioned to write the cascaded form structure. Again, cascaded form structures, it's very easy. I have told you how to do it in my lectures as well. In this, they have given the h of z sequence as h of z is equal to 1 plus 1 by 4 z inverse plus z to the power minus 2 into 1 plus 1 by 8 z inverse plus z to the power minus 2. Now what we should be doing is, we should be splitting these two terms separately as h1 of z and h2 of z, and solve these two separately using the direct form. These two separately solve using direct form. First check for the linear phase condition. If it satisfies the linear phase condition, write the structure as according to the linear phase only. Okay, so do first consider h1 of z, that is 1 plus 1 by 4 z inverse plus z power minus 2. Check for linear phase condition here. If you see that first and last term coefficients are same, that is 1. So linear phase condition is satisfied for this. So the structure would be like this. We have two delays, so two blocks one below the other. I'm not going to explain this in detail because I have explained it in my theory classes, so you can note it down. Okay. y1 of z is equal to, since this is a transfer function, so y1 of z by x1 of z. So I have directly multiplied x1 of z to this term. Then take the inverse transform. So this would be now y1 of n. So that would be equal to x1 of n plus 1 by 4 x1 of n minus 1 plus x1 of n minus 2. For this, write the direct form structure like this, okay, in this way. Since first and last term coefficients are same, so if you draw like this, so we can directly from this point to this point, we can directly take a summation and write the common coefficient, that is 1, and we can add these two terms. Along with that, this term should be added, so that's why we should be adding one summation here, and from this point the coefficient is 1 by 4, so add these two coefficients and our final output we will be getting it as y1 of n. Okay. Similarly, h2 of z, solve it. Again, this satisfies the linear phase condition. Okay, I'm not explaining it again. So write the direct form structure, copy it down. So now how to write the cascaded form structure? Now the output of the first sequence should be joined with the input of the second sequence. That is, these two would be joined now, and x1 of n would be, the input would be changed to x of n, and the final output y2 of n would be changed to y of n. Okay. These two structures, write it as it is, and the output of this first structure should be joined with the input of the second structure. Okay, that's one change itself, and write this cascaded form structure according to the question. Okay, so this was the question here. This would be coming for around 5 marks in the exam. So please note it down. Some of the rules of cascaded form, it is very important to know. So this was the solution, guys. Note it down.